Once you have the concept of runtime stack, let's take a look what is happening. And we start with learning by looking into a little bit more complicated recursive function call. So in this recursive function call, it takes two parameters instead of one. So it takes two parameters. One is the value of A, the other one is the value of B. It will start with initiating a result variable equals to 0 to hold the values that we want to do the return. So you can see whatever it is, return value equals to the result value. When b equal to 0, which is our base case scenario, our result equals to 0. Simple one. If not, if this is hitting the general case, which means that b is equal to greater than 0, then result equals to the value of a plus function call, still the same value of a, but b will have a -1 in here. Hopefully, it will bring the value closer to b equal to 0. So you can see that based on this code, if we try to use a main function called function 5.2, think about this. What is the return value is going to be? I need you to pause the video, try to find out what is the output of that. By doing so, you can have a full understanding of what's happening inside of this recursive function call, and I'm going to use that to talk about the runtime stack. So please pause the video, try to find out what is the correct return value here. Assume we come back from the process and get the return value. Let's see if you get it correctly. So look into this value. When function 5.2 is called, it will call the function because b is greater than 0. It will hit the general case. The result will equals to a plus function of a b minus 1, and that's why it will equal to 5 plus function 5 1. So when that is called, a equal to 5, b equals to 1, which is greater than 0, so it will hit the general case again. Result equals to a plus function of a b minus 1. So you will see when this is function call, it will call a equal to 5, b equal to 0. That is going to hit the base case scenario, so the result equal to 0. Since our return value equals to the result value, this 0 will be returned back to where it calls it, and therefore you can see that result equal to 5 plus 0 equals to 5 now. The 5 will go back to where it calls it, so you will end up with result equals to 10, and 10 is going to be the value returns back to the main function that calls it. I hope you get this part right. So you can see that in this whole process, you need to remember several things, including the parameter of a and b values, the result value, and what is the return value going to be. So when that is happening, you can see a whole runtime stack need to be processed for every single recursive function has been called. Remember, where's the a value, where's the b value, what is the result value, what is the return value, and where does this return value returns to, so that you need to remember the return address over here. When this is happening, because it's going to hit the general case, it will call a function call. So now a still 5b become 1, calling the whole function because the result equals to 5, which is a value plus function of 5.1, a and b minus 1. So when this is called, that's why we have this runtime stack. Remember where's the a and b values going to be. Now result value, since this is going to be a general case scenario, so the result value is still equal to a plus function a b minus 1. So you will call this function 50. That's why we have a runtime stack on top of it, a equal to 5, b equal to 0. When this is happening, because it hits the base case scenario, so the result value equals to the return value, both of them are 0, it will return to back here. When you do that return process, you can see this whole runtime stack is popped away, and therefore we can pop it out, getting the result equals to 5 plus 0 equals to 5. And we will have that returned to the place that calls it, and therefore we will be able to get our value of result 5 plus 5 equals to 10, which is the value that we returns it. So you can see this is the whole process. You have runtime stack being pushed on top of each stack. When it finally hits the base case scenario, it can be popped away and then start to reduce the runtime stack process. So this is the idea that I want to introduce to you guys. In order to learn it in a better way, let's take a look a little bit even more complicated situation. So based on the code that we see earlier, I make 3 modifications here. The first one is that when b equals to 1, we make it as a base case scenario. Result equals to b. So when it hits the base case, result is equaling to b instead of 0. The general case wise is following the same thing. The only difference is now a and b value will both change whenever we call around the recursive function call. So when this is happening, I want you to do the same thing. Take a look of this code saying that the function call is 20 and 4. A equals to 20, b equals to 4. I want you to bring out your pen and paper again. Try to find out what is the return value. And this time we're going to solve the whole problem in a runtime stack manner. So pause the video, work on this one, try to find out what is the expected output going to be. Now assume we come back from that process and let's see what is this supposed to be. I use this big table to help you keep track of the runtime stack. So in the very beginning, when A is 20, B is 4 called, we have this simple runtime stack. Need to remember where is the A value, what is the B value, what is the result value, what is the return value here. You may notice I take away the address because address is for operating system. It is crucial to the operating system, to the computer. But for human, they are usually a long hexadecimal numbers that are not very meaningful for us to keep track in the process. So I omit it. But in real runtime stack, of course, it need to have that address to return to. So let's see what's happening. When this runtime stack is called, result value equals to 20 plus function of a minus 5b divided by 2. So it becomes 15 and 2. And because of that, we will end up with one more runtime stack on top of this. So you can see this is a T1, this is T2, T3, T4, and T5 for each column. I abbreviated this box, which is empty over here, is supposed to have exactly the same code. The values all copy and paste over here. I just take it away so that this table can look a little bit more cleaner. So you can see the idea is that we have a runtime stack on top of this stack. Now we have a result value equal to 15 plus f of 10 and 1. So when that happens, of course, f at 10 and 1 we'll call a runtime stack. So you can see that this block is supposed to be equal to this value, this block equal to this value, and we will end up with one more runtime stack on top of it. A equals to 10, B equals to 1 here. So now we hit the base case scenario since B equal to 1. So the result value equals to the value of B, which is 1. And return value is the result value, so you will return another 1 over here. So when this is done, you can see that this value can be passed back to the place that caused it. So we can pop this away and then goes to the next timeline, which is T4, getting that value 15 plus 1. So we have this value here, and because of that, we have the result value, and we can generate the return value now. So when this return value is generated, it will be able to return back to the place that caused it. And you can see originally we have this whole value stored over here in reality, but I just abbreviated, so it's actually the same values here and here. So you can see 16 will be able to pass back over there, and that's why we will have a 16, which is the value that passed back to it, plus 20 equal to 36, and that is the value for us to return, and therefore you will be able to return the value of 36. I hope you get it correctly. So after the whole process of this runtime stack, I think it is time for us to have some practice, and that's why I'm going to give you an assignment over here. It's the same thing. I make some modifications over here. Take a look of this function, takes 2 parameters, result equal to 0 and then if the base case b equal to 0, result equals to the value of a. Else if b greater than 0, then result equals to a plus function a multiplied by 2 and b divided by 2. So these two modifications are pretty simple, straightforward. However, the return now no longer equals to the result anymore. Return value will equal to result plus a value here. So pay attention to this one. Try to understand what is happening in each runtime stack. So you need to keep track of the a value of each recursive call, and then try to get the result value. When you're ready to return, don't forget to add the a value here. No matter it's coming from the base case or the general case, the return value always equals to result plus a. This is a runtime stack I prepared for you guys. So use this runtime stack table to show me what is happening in each time frame and tell me what is the final return value. This is going to be a little bit more challenging than any other assignments that you ever have. So start to spend some time, dig into it, understand what is happening, find out what's the values. I have prepared a very nice slides for the answers of this assignment. So go ahead, work on this one, submit your assignment through the Blackboard. After the due date, you will see what is really happening over here, even if you did not get the right answer. However, I really hope you can get the full credits out of this assignment. And that is the video for us to see here.